JavaScript is absolutely compiled, and there's one simple way to prove that to yourself. Write a JavaScript program that's 10 lines long, and on line 10, leave off a comma or add an extra parenthesis or something, make a syntax error. When you try to execute that program, you'll note that lines 1 through 9 do not actually run. You don't see their outputs in the console, for example. You get immediately a syntax error reported to you about line 10. And then ask yourself, how did JavaScript know that there was a syntax error on line 10 without having run lines 1 through 9? The answer is because it doesn't have to run line by line. JavaScript is not, in that sense, an interpreted language. In that sense, it's a compile language, meaning that there's at least one pass through the language to compile it for syntactic correctness, to plan out the scopes, all of that other stuff. And then there's another, at least one pass of execution where there is a virtual machine in the JavaScript engine that's interpreting that compiled bytecode and executing those statements on the system. So in that way, the idea of interpreted versus compiled, it's usually like a question about how we distribute the code, but actually we should be thinking about how is the code processed. Is it one pass? Like, for example, a shell script like bash script. There's no pre-processing on that. It's just going to run line 1 and then 2, and if there's an error on line 3, you won't find out about it until line 3. But for languages like JavaScript and basically almost every other programming language as well, there's at least one pass where the compiler will find those errors before it's run anything. So again, I would say JavaScript is absolutely compiled no matter what anybody says. So the idea of a pure function is a function that embodies what we call referential transparency. That sounds like a fancy term, but it's actually pretty straightforward. It's the idea that the function call should take in one or more inputs, or maybe not any, but usually at least one or more inputs, compute some result and return a result. And it should do that in a way that doesn't alter any of the other program state. And the importance of referential transparency is that I could take whatever that computed return result was and replace the function call with the return result and not affect any of the rest of the outcome of the program. And if that's true, then that function call has referential transparency. In other words, it was a pure function call. The reason that's so important is that that's how we isolate lines of code and understand them without having to execute mentally all the other lines. So on line 10, if you call a function call and it has some kind of side effect to it, and all the other lines before it have some kind of side effect, if you want to understand line 10, you have to mentally execute lines 1 through 9 first before you execute line 10. And you have to do it perfectly because those changes to the program state might affect how line 10 actually executes. As opposed to having, say, all of these steps that are pure, or even just line 10 being a pure function call, you don't need to compute any of lines 1 through 9 because they're not going to have any effect on what line 10 does. So that allows us to isolate a line, run it either mentally or actually, come up with some outcome, and then debug that outcome if it's not what we want, without having to deal with the other lines. So that is one of the important reasons, and sort of in a broader sense, avoiding side effects is how we avoid bugs in our code. So the functional programmer knows that the side effects, while necessary in some cases, should be minimized as much as possible because they are the way that unintended things happen in our code. And that's where bugs come from.